So today's class will start quickly. In the last class, I have shown you two steps, right? I just showed you how the data will be uploaded on your Google Colab. Okay. You may have been using any other application in your system, in your organization. It may differ. Only the difference will be the tool. The process still remains the same. We will go through it. But whenever you are uploading your data into this platform where you want to run a machine learning, you have to clean the data. That's the first and the foremost task you have to do. Why cleaning of the data? Because your data may contain noise. Okay, that's the word which you use. Noise means the data which is not good or not fit for your analysis. For example, you are taking a particular data set from the server logs where every time when the server log is writing, or maybe after every few minutes when it is writing to a log, it pauses after some interval and a new line character is added. A new line character means a blank field gets added, a row, right? So when you import that data onto your CSV, your data will show you all empty fields. So if the data is empty in the field of row and column, then that data makes no sense to be kept, right? Why you want to use that data? So basically there are strategies how to handle the data. Second strategy is you may have data where you have a duplicate records. When I say duplicate records means your data is repeated exactly in the same way multiple times. An example would be, let's say you are hitting a website on a service layer where one service is failing. Right? Let's say you are doing an Amazon check-in and checkout. When you're clicking on checkout, add to cart and checkout, proceed to payment, that API is failing. Right? So server is continuously returning HTTP 500, right? The log will still remain the same, right? HTTP 500, HTTP 500, 500 multiple times, right? If your data is repeating again and again, why you want to keep all the data set? Why not keep only one, right? So normal strategy is, not normal means basic strategy is, whenever you get a duplicate data, you just remove the data and keep only one occurrence of the data, right? If you keep multiple occurrence, there may be a need of keeping multiple occurrence if it is time stamped. Every second and millisecond is different, right? So data will have a separate millisecond, then it is fine. But if the data rows and columns are repeated again and again with all the columns matching to each other, you simply remove the unwanted rows and keep only the one row, either the first one, middle one, or last one, whichever you want to keep. Clear? This two task is called as data cleansing. Okay. Then the concept of pre-processing comes is identifying a feature and feature encoding. Okay, I had a very tough time in explaining other class feature encoding. I want to see how you all can understand. Feature encoding is a technique in which you convert a non-numerical data into a numerical data. Clear? Non-numerical data. Numerical data, everyone understand?
Yes.
If I have age is a number, right? Salary is a number, right? Machine very finely manages numerical data because it doesn't have any problem in dealing with numerical data. Machine has a problem in dealing with the text data, right? A text data may be, let's say I have a department which has got multiple, let's say there is a college which has got multiple departments. You have IT department, HR department, engineering department, support department, and many departments, right? The data is written in a form of a character, right? Or a string. Machine doesn't understand this. The strategy involved is called encoding, where you number the particular type of data into a certain number format. Classical example is if there are gender can be male and female, right?
Yes.
So if I give a number male as 0 and female as 1, right? Wherever in the column male is coming, I will put 0, 0, 0, 0. Wherever female is coming in that column, I will put it 1, 1. Right? That's one way of encoding it, right? Other way of encoding means maybe, as I told you, department, right? So there are 20 departments. I name the department as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if a particular department is appearing multiple times, I put that number adjacent to that particular column. Clear? That mechanism is called encoding. Without encoding, feature encoding, you cannot do machine learning algorithm. It will never happen that you will get a data set which is all numerical. Forget about it. You will have a data set in the column which has got both numbers and characters or string, right? First step is cleaning the data, and second step is feature encoding. Okay. Once you do the feature encoding, whatever I'm telling you is more of a overview what is written there, right? So just first understand. Once you do the feature encoding, then is something called as feature aggregation. Aggregation, you understand? Summing up, combining together, right? So feature aggregation is a process where you take a particular set of column and aggregate to form a single column, right? Example is, let's say there is a cell of data of a particular store sales. Okay, you have a product listed out in the, not product, let's say you have dates, 1st Jan, 2nd Jan, 3rd Jan, 4th Jan, like this, right? Every date, and you have average sales on every day. So in a month there are how many days? Let's say 30 days. So you have 30 days all data of average sale, right? You can use all the 30 column to determine or predict something. By why to use 30 column? You merge all the column to form a single column called as monthly sales average, right? What is the advantage of reducing the number of column is, I told you last time, we have to come up with a concept of dimensionality reduction. We want to bring the data into 2D or maximum 3D format so that we can visualize and understand it. If I have 30 columns of average sales, and if I draw that 3D or 5D or 7D diagram, you will not understand anything, right? So feature aggregation helps in reducing the number of columns. Each columns are combined together. When I say combined together, it doesn't mean you add it like column A plus column B plus column C. No, it's not adding. It's concatenation of the columns. Column A, B, and C. Let's say it's a sales average. My concatenation will be string A, comma, string B, comma, string C. Concatenate, joining it, but doesn't mean adding it. Okay, it's treated, the data of 3 columns is treated as a single array. Now that column is defined as one column. Clear? If you understood this, you are good to start. Any questions till this point? No questions? Very good. Okay, so this is the link, you all can read it. Not reading it. Data object features. Data objects are described by the number of features. So any column which you see in the raw data in a CSV format, each column is called as feature, right? And you will treat each column feature as an object, right? Object means, what is object? Things. So objects are defined as something which is having certain features and certain methods or functions. So let's say if I define a category man, okay, for people who don't know C, C++, think about man is a class. When I say class, man is a type of an object. I say man will have attributes like 2 hands, 2 eyes, 2 legs, right? What is his feature? He can run, he can sleep, he can dance, he can eat, roll over, eat. Man has an attribute of certain feature, 2 hands, 2 eyes, right? That's a feature. Functionality is what can man do, right? Man can run, sit, sleep. So I defined a category, right? Now, if that category is replicated on Mr. What's your name?
Mayur.
Mayur. If I take man and call it as a Mayur, can I say Mayur will have same feature what man is defined?
Yes.
That is when Mayur is an object of the class which is man defined. So Mayur will always and always have 2 hands, 2 legs, 2 eyes, and 2 ears, and he can run and walk and sleep whatever he wants, right? Right? Understood? So whenever you are creating a data object as described by the number of feature, means whatever column it has, that captures the basic characteristics of an object. Example, man and example, right? Objects such as the mask of a physical object of a time at which an event has occurred, etc. Features are often called as variable, characteristics, field, attributes, or dimension. You will find the word feature, variable, characteristics, field, attribute used interchangeably in the documentation. If you are confused, forget about all the words, just remember feature. feature are nothing but the column names which are defined in your source data, right? Each column, when it is defined as a source data, let's say if a column is defined as gender, it has got feature as male and female, right? That's its feature. If a feature is defined as a salary, a feature is defined not as a salary. Let's say a feature is defined as years of experience, it can range from 0 to 100. So it can have 100 different types within that variable. Okay. So this is important. So data features of only two categories. Okay. I told you in machine learning, you deal with only with numbers. Okay. But data is not always a number. So your data types are defined into two categories. One is called as categorical, another is called as numerical. Right? In numerical, you will have two categories. One is called as interval, another is called as ratio. Okay. You don't have to worry and learn more about it because numerical data is fine with you because it's always a number. Interval is defined because every data resembles certain types of iteration or occurrence. For example, if an age of a person is given in the column, can it be 999? Yes or no? Yes. How a person age can be 999?
That kind of like numerical data can see.
Two numbers, right? Or maybe maximum 100, right? And it will reappear. The important aspect of interval means it appears at any interval. It may appear in a certain format of interval, it may not appear at certain format of interval, but it will appear. Age of a person can in a group of 50,000, 50 million people will have reoccurrence, right? After certain interval or at any interval, right? Your numerical data also consists of ratios. Ratio, you understand?
Yes.
Define ratio.
It has
Numerator
numerator
and proportion.
denominator.
Tell me about ratio.
It has numerator and denominator.
One is
I mean,
one characteristic in relation
one is
to
to
another. One milk, two sugar.
Come on, guys, what is ratio?
Yeah,
Don't tell me you have not studied.
Enough.
I'm not asking proportion. I'm asking you ratio.
No, two numbers.
yeah, one characteristic.
Mean of two numbers.
it's like
Ratio in a simple sense
If
is
you
a
have a
split of a data
split, yeah.
into different
division.
groups. If I draw a circle and if I divide it by half, what does it mean? 1 by 2,
50%.
half, 50%. That's a ratio, right? If I divide it by 4, it is 1 by 4. It's a split of the whole data into different segments, right? The numerical data can be interval or ratio. Important is this categorical data. Categorical data is a data which is more of a character related set. As I told you, character cannot be run on machine. So what you have to do, you have to convert it to numbers, right? So character data is defined in two categories. One is called as nominal, another is called as ordinal. Okay. Nominal basically means having certain predefined range. Nominal means having certain predefined group. Like for example, political party, Democrat, Republican, Green, and other, right? Certain specified group. Ordinal means doesn't have any specified group or range. Like t-shirt size, small, medium, large, extra large, double XL, triple XL, right? Correct. So one small, someone small is different from some other small, right? You don't have, you have range, right? But you don't know exact range when you put it in the small, medium, or large category, right? Another example of this is when you have this rating, you know, 1 star, 2 star, 3 star, 4 star. When you do a restaurant rating, someone has given 4 star and someone has given 3 star. What is the quantification of 3 versus 4? Your 4 can be my 3, right? Your 5 can be my 4, right? So when you don't have a range, you define it through ordinal. Okay, ordinal in a simplistic term is called as instance of match. Okay, when you don't have a predefined range. Nominal is always defined range, right? You have a 5 political party, there is 5 only. If it comes 6, 7 every time it is changing, then it becomes ordinal. When it is fixed, defined range or defined category, then you call it as nominal. When it is not fixed, you have to identify how many of that exist, then it becomes ordinal. You can have 1 match, 2 match, 5 match, 10 match, 50 match, 100 matches. Okay? Clear?
Yes.
Category feature whose values are taken from the defined set of values, for instance, days in a week, numerical represented by number. Categorical data is nominal for days of week. 0, if Sunday is 0 and Monday, what is Saturday is 7. 6, 0, 1, 2, 3, 4, 5, 6. Right? Can there be 7? No. That's a categorical, what is that left on? Nominal data set. Clear? If I say number of months in a year,
Same category.
fixed 0 to 11. And we deal with the data in machine learning always starts with 0. Okay, whenever you do the feature encoding, like converting numerical data, character data to numerical, you always start with 0. Okay, what is ordinal data? If I ask you that there are 50 departments, there are many departments in this college, right? One college may have 10 department, other college may have 15 department, third column may have 20 department. Can you define a limit like, okay, it should be 5, 0, 1, 2, 3, 4, 5 or 0, 1 to 9? It will change depending upon the data parameter, right? So if you take a data set from a college which has got 10 departments, then it will be 0 to 9. If you take another data set, machine will find it out, oh, it has got 20 departments. So it will label it from 0 to 19. Clear? Everyone is clear till this point?
Yes.
Very good. If you don't understand, pause me. Steps in data pre-processing, data quality assessment and improvement, feature aggregation, feature sampling, dimensionality reduction, feature encoding in particular for images. Data quality assessment and improvement is done. Feature aggregation, I told you, combining the number of columns, different columns to create one major column, right? Feature sampling is determining the data from the sample. Where should you pick up the data from? If I am an Excel sheet of 50,000 record, which section of the data I should pick it up from training and which one I should pick up from learning, training and testing. Last time I showed you an example, right? Training and testing, right? I told you select any random, right? So sampling is very important when you do feature assessment, running the machine learning algorithm. Clear? Dimensionality reduction, you know, right? Reducing the axes, right? X, Y, Z, P, Q, R plane, you reduce it into 2 dimensions. We'll see how it is done. Feature encoding, I explain you, converting a non-numerical data to a numerical data. Okay. Data quality assessment is problem and resolution. What to do when these situation arises in front of you when you get the data sets, right? When you get a log data, the first part is pre-processing, right? Pre-processing, I told you have to clean the data, right? So what are conditions you will see? The first condition is missing value. You will have a row of data which has got some incomplete data, right? So let's say classical example is your assignment submission, right? If I take out all the student assignment by name and all the assignment, right? If I see some assignments are not submitted, right? It may happen, right? Some empty will be there. Not all the field will be empty, some columns will be empty. What to do with that data set? So there are 2 options you do. You eliminate record with missing value. You right click at particular row and delete it. But you cannot delete a student, right? Delete it, he is no more in the system, right? So other is estimate the value and replace it. So if let's say your name, what is your name? Mayur. If Mayur has 7 assignments, right? He submitted 5 and not submitted 6 and 7. So what should I do? So think about Mayur's name is on the left hand side with all of the students' name. Assignment 1, 2, 3, 4, 5, 6, 7, midterm, final exam and quiz, right? All those columns are your grades, right? Mayur has submitted from 1 to 5, missed 6 and 7. That field is empty. One option, I cannot delete it, right?
You give a value.
How should I give a value?
Give you full marks.
Based
Complete
on the other assignments. 50%.
Not completed means 0.
Not completed means 0. Again, this is not a best example, but so what you do is you determine the column where the value is 0 for him. right? I took all the students' name for that particular column score and take a mean value of it. Somehow I have to give some number there. So basically I will take all the students, like 32 students are there. I will do a mean of it and take that number and paste it there to fill that empty space. First is, if the empty column will be there, my machine algorithm will fail. So I'm just filling it with the most appropriate value. Mean, if I put a mean, will my data variable change? It will very little move from this mean point, right? Because it will have the same mean value, so it will not deviate left or right. You understand, right? If it is if a value I put a mean value, mean will again take a mean of it, it will still be the center point, right? It will not change, but at least my algorithm will work, right? So one option is estimate the value and replace it. You estimate a value of a mean. Most commonly way of using is mean or finding a 95th or 99th percentile. Is percentile?
Most repeated value.
Who can explain me percentile? I will give 5 more marks.
Anything over 100.
Huh?
No, it's
Anything.
percentage.
So
Nobody will look at the Google, okay? What is difference between percentage and percentile? I give 1 minute for percentage. I will give 5 marks more in the exam.
Percentage.
percentile is the like a value which is like most occurring in the like sequence. Like suppose the one value is like 95% in the like range. Another value is like in 80% range. It's like those sequence.
Is it
Percentile is
a
like,
value over 100?
Used to express score in percentage.
like what? Give example.
Nobody knows what is percentile.
Like
Everyone know what is, yes, go ahead.
it's like somebody got the first place in the class, like in grading. If Mayur get the highest point, then he's just one person. So 1 upon how many people, how many students he
Are above.
like, yeah, how many students are behind of him
No.
in the results.
Yes.
So in a range, for example, from 0 to 100, you try to find the position. The percentile is more like
Very
the
good.
Position.
you are. So,
Very, very good. But how you do it?
so if you are between maybe 90 to 100, you are part of the 90th percentile. That will be the number of people divided by 100 times.
I will tell you a very simplistic way to
Divide
remember in
by
your
two.
life. Okay. Percentile is first of all is not percentage. Okay, it's not percentage, but it is a subcategory of a percentage. How do you determine percentile is? Whenever you have a data of numbers, whenever let's say there are 100 numbers, I'm making it very simple. If you have 100 scores, someone got 10, somebody got 15, somebody got 18, somebody got 52, somebody 57, right? If you have all the score, if you arrange all the score first in ascending order, first step, take all the number, arrange it in the ascending order, right? Find the 90th position or 95th position. So how will you find it? Take the number, divide by number of occurrence. Find the 95th position. Wherever your arrow goes to the number, the percentile means either your score will be that number or less than that number. That's the mathematical explanation of 90th, 95th, 98th percentile. So whenever you give an exam, they tell you I got that much percentile. Basically, your scoring is arranged with all the people with a lower to higher, right? Then determine which position your 95th percent comes. So the position where that 95th percent comes, the value at that person is rank 1, and everyone will be graded below that. So if it's 95th, 94th, 93rd, 92, 91 percentile. So this is an interview question I always ask. So what you do is either you can find the mean value, find the standard deviation, find the 90th percentile or 99th percentile. Okay. Your 99th percentile will be the last value, nobody will be ahead of it. Either your value will be that or lower than that. Okay. Inconsistent value, investigate inconsistency of the data type and act accordingly. Inconsistency data type means if age is there, somebody put ABC. Right? So what should I do? I determine inconsistent data and convert into the format which is more appropriate for that column. Duplicate value, in most cases, duplicates are removed. So when I say duplicates are removed, I keep one instance of match. I don't delete all the duplicates. Clear? Feature aggregations are performed to take the aggregated values in order to put the data into better perspective. Example, average daily sales. I gave you an example of that. This results in reduction of memory consumption and processing time. Aggregation provides us with the high level of views of the data as the behavior of groups of aggregates is more stable than the individual data objects. So if you aggregate it, it is more, I would call it more comprehensive in terms of the data column you have merged together, right? So it is more appropriate to use aggregation. Feature sampling, selecting a subset of the data set what we are analyzing. The key principle here is a sampling should be done in such a manner that the sample generated should have approximately the same property as the original data set, meaning that the sample is a true representation of the original data set. Right? You don't take sample from top row 1 to row 20. Right? You take, and you don't also take it at random. You need to analyze the data. We will see how the sampling is taken. One example to do the sampling identification is using heat map, right? Density plot, right? So I gave you an example, like if you have a population in Canada and I want to know, predict how the voting will happen, I take more samples from higher density data set rather than the less number of people staying in a particular locality, right? Then only my proper sampling is happening. Dimensionality reduction feature is also called dimension. Dimensionality reduction means to reduce the number of features. It appears the feature selection, the important for visualization because each feature generates an axis. Combination of axes generates geometrical plan. What dimension reduction essentially does is it maps the data set to a lower dimension space, which may well be a number of axes which can move now be visualized as say 2D. The basic objective technique that which is used for this purpose is to reduce dimensionality of the data set by creating new features which are combination of old features. Dimensionality reduction, I told you, you have to reduce the data into format which is less of dimension. Less of dimension means if you have 5-6 column, all the column are of temperature of every day. Monday, Tuesday, Wednesday, Thursday, Friday, right? Why you need 5 column for temperature? You merge it to form one dimension temperature column and use average for all the number there. Clear? Yes. A few major benefit of dimensional reductions are data analysis algorithm work better if the dimensionality of the data set is lower. This is mainly because irrelevant features and noise have now been eliminated. Models which are built on the top of lower dimension data are more understandable and explainable, means it's easier to understand in the graphical form. The data may now get easier to visualize. The feature can always be taken in pair or triplet for visualization purposes, which makes more sense if the feature set is not that big. Again, we will see it how to do it. Okay, feature encodings are of multiple category. I would like you all to read about it. Again, I'm not going to the details of it, but the most common ones I will show you how to learn about it. Feature encoding, I told you, converting non-numerical data to numerical data, right? A very common one which is used is called as label encoding. We will do our program with label encoding. Okay, label encoding is basically has a type called as nominal, right? Supports high cardinality. How many of you remember what is cardinality? Who will answer me? 2 marks if the person answers. Come on, cardinality. Specs guy.
How many relationships or how many connections? Something like that, sir.
Anyone to add over it? Cardinality, guys. How many of you have studied set? Venn diagram. Venn diagram. Right? Everyone studied. Union, intersection, Cartesian product, cardinality. Yes.
Number of elements in that set. That's
Okay. You people read it in the home. I'm not going to tell.
Number of
Cardinality is the relationship of the mapping between two sets. Okay, so there are many encoding techniques: label encoding, ordinal encoding, one hot dummy encoding, target encoding, frequency count encoding, binary encoding, and hash encoding. I'm going to explain you about three which are most commonly used. Label encoding, everywhere it is used. Most common, most easiest of the all. Label encoding basically gives a number. 0, 1, 2, 3, 4, 5, how many different types of data set you have, right? Binary encoding deals with only 0 and 1, very commonly used when you have category of zeros and ones, right? Like male and female, right? That's a very common way of using. But you can use binary encoding in label encoding also. Okay, binary encodings are used in places where you have to make a decision, either yes or no, right? Label encoding doesn't give you a decision. Okay, label encoding is always with a number that helps you in prediction, but binary encoding helps you to make a decision. Okay, if this situation happen, what to do? Either yes or no. Hash encoding deals with using hash function. Okay, you can write your own hash function and use it in the encoding technique. So every hash function has a unique encoding parameter. You pass that parameter to the variable provided in that column. Okay, others you can read it, but I will in our course we will cover this portion. This is the one which we'll use today and we'll use it in the exam. Okay, this is the easiest one. Cleaning data in Python, this is a URL, you can go down, it's a free, you can write your code here and execute it. If you don't want it, fine, no need to do it. Because I'm not going to use this is a childish one. Okay. Data types constraints are common data types, numeric, text, and dates. These are the very common data types you will see in the raw data set. Either it is numeric, either it is text, or either it is dates. Summing strings and concatenate numbers. Summing strings and concatenate number, recognize numerical data versus categorical data. You first determine in the rows and column which are numerical data and which are categorical data. Numerical numbers can be imported as a string. You can import it as a string. Then mathematical operations such as summing and multiplication lead to string concatenation. String concatenation, you understand, right?
Yes.
Not numerical output. String number should be converted to integer first. So if you have to join two column, right, you have to first convert those numerical data to string, concatenate, and then convert it back to the integer. Okay. Categorical value may also be need to be converted to the integer format, which is nothing but an encoding technique. Don't worry, it looks very difficult, but when I show you, it's very easy. Finding duplicate, treating duplicate, drop complete duplicate, collect statistics of value where some aggregations are collected. For example, average value or means. So in case your duplicate arise, either you remove it or you take the sum average of all the 5 duplicate and create one row and remove all the 4. How many of you understood this, what I said? Repeat what I said.
Then about the aggregates, the rows, you can either take all of them or remove some.
What happened?
So let's say there are 5 duplicate. One option is remove 4 and keep 1, right? Second option is if you have 5 data, average all 5. Average all 5 for all the columns and add one row and remove all the 5. Clear?
But what's the point of aggregating, because all the values are gonna be the same anyway.
Very good. Rather than 5 column, 5 rows, I will have only 1 row. That's the advantage. So when you have 1 row, your processing speed will be faster, right? You will need less computation. You will need less memory, less CPU to process it. If I have 20 million records, out of the 20 million record, if I have 50,000 data scattered in 20 million here and there, you don't know, right? And then you identify duplicates are appearing 50,000 times. What's good strategy? Either you delete it, so you save from 20 million will be 90 million, 50,000, right? You save little bit space for memory, or you delete everything 50,000, make one row for it. Advantage is CPU and memory computation, right? Find the duplicate and again verify. You have to retest again and again. So you can check one duplicate at a time, second duplicate, third duplicate. You can iterate it with a for, while loop and whatever, and you can remove it. but nobody does with while and for loop. I will show you with the algorithm. It directly does it in one command. Okay. Other operation in data pre-processing is raw data normally contains lot of noise, gaps, and garbage. Data pre-processing requires data to go through splitting, merging, wrangling, and pivoting. Splitting means breaking the data set into smaller chunks, which you do it in the Hadoop. Merging is reducer, right? Wrangling means is a process of gathering, organizing, manipulating data to ensure its quality, consistency, and suitability for the analysis. Basically, feature encoding and removing duplicates, right? Removing empty data set. And last one is called pivoting. Excel pivot, everyone knows? Pivot table?
Yeah,
That's it, same. Process of by enabling data scientists to reshape the data into more suitable format. You don't have to create a pivot table. There is one command which is called as data frame dot shape. That does everything. One line, right? You don't have to determine the shape of a pivot table. It gives you with a single command in order to achieve more effective result of core algorithm of data analytics. In machine learning, pre-data processing is needed to bring images to the state where they are readable by the machine encoding. Demo is assured. You people can read it, but not required. You can go this link. Okay, it's a good demo. Someone has presented it, but up to you. Top 5 tools are Gardener. You all can read it. Okay. I will cover one more slide and then we'll start with programming. Okay. So the earlier and faster you people digest it is better. We can start quickly. Okay. So whatever data pre-processing we have done, the first step was data pre-processing. You clean the data and you process the data. Now the second step is to visualize the data, right? Data visualization is nothing but plotting into a diagrammatical view in form of a chart, pie chart, bar chart, histogram, heat map, plots, density map. There are hundreds of graphs in the world, right? You can use anything, any format, so such that your data is a representation of what's happening inside it. Okay, so if I give you Excel sheet of 5,000 record of average sales of a product of a Walmart, will you understand? You will not understand, right? Unless you say, okay, you select column A, B, C, and go into the graph and draw graph, right? It shows you graph. So once you see the graph, you will understand, okay, what's happening, right? So visualization is the same concept using the machine learning algorithm. Visualization directly uses the function which you can directly use to depict the graph format. It is helpful in making decisions, okay? Visualization resources rely on powerful tool to interpret raw data and process it to generate visual representation that allows human to take and understand the enormous amount of data in few minutes. Okay, pause me if you don't understand any line. I'm going a bit fast, but my objective is to show you something. Okay, data visualization describes the data of almost any type, number, trigonometric function, linear algebra, geometric, basic or statistic algorithm in a visual basic format, coding, report, analytics, graphical interaction that makes it easy to understand and interpret. Visualization is way to deliver result of data processing, often the result of data analysis. Big data visualization techniques are important because they enable decision maker to understand what the amount of data means very quickly, capture trend. The use of appropriate technique can make it easy to recognize this information, reveals pattern, identify correlation and unexpected connection that could not be found with the specific question, provides high effective way to communicate any insight that surfaces to others. So these are the types of big data visualization. One is called as chart. Charts may be pie chart, bar chart, histogram, pie chart, whatever it is, line, right? Plots are XY plots, scatter plot. You have seen plots, right? Maps, heat map. Have you all seen it's called a periodic table?
Yeah.
Heat map is like that. Basically, heat map says the density will be more, the value will be closer to 1. If the density is less, it will be farther from 1. Okay. Kernel density estimation is nothing but a bell curve. Okay. Box and whisker plot is a plot which is depicted by boxes with the line in between is a mean value. Okay. Where do you see this box and whisker? Not seen?
Stock.
Very good. It's seen in the stock market, right? They have this vertical box, right? And you put a
Candle.
mouse, it will show you the expanded box.
Candlestick.
A candlestick. Very good. Word cloud is like that. If I have to tell you, determine how many times a particular word is used in a book or a novel of 5,000 pages. So you can get a word view, like which words are most commonly used will be most common will be the biggest in the word category in the depiction. Network diagram is nothing but a DFT diagram, a data flow diagram, connection between different nodes like a neural network. Correlation matrix is the matrix where you correlate the two column of the data. Let's say I want to correlate age versus year of experience. Correlation matrix shows in XY plane. Okay, it's not like a plot graph or a, what you say, is it like a Venn diagram? Let me show you in diagram. Is that correlation matrix, right?
Composition.
You see this one? It's not heat map. It's a relationship between two entities like HP versus SP will be the one. So if I take a one column to correlates on its own is 100% match, right? If you take hypotenuse with the displacement little bit match, wet skew sequence, something like that, right? The farther you go from the correlation, it lighter it becomes. Okay. Okay. Next, consider a specific goal to build a diagram. Think about a viewer, make the diagram easy to understand. This is all theory. Okay, I'm just reading it. Avoid 3D, make preferences to 2D. Set focus by selecting color and fonts. Compose visual object on the screen. Think about eye movement known as saccadic eye movement. You shouldn't draw a visual representation where a person has to go like this. Don't draw panoramic graph. Okay. Don't overload the dashboard with visual feature. Don't add too many graphs. Make the important message obvious in visual features. Okay. Limit time wastage on saccadic movement. Okay. Visualization issues, viewers need to trust to summarize vision, miscommunication or over communication of the performance measure, relevancy of graphical image and content, space constraint, color, font, and etc. These are some of the challenges you face. Any question in this slide?
No.
What is visualization with color?
It's like very bold.
The lady after you, the guy up, lady. Yes, yeah.
Visualization in
Color.
color.
What is the issue?
Colorblind people.
Very good. If you have a website which doesn't have a accessibility features, the person with color blind will never see it, right? Very good.
Are those people sensitive to like those bright colors? Like
So how should I do?
no, don't use them.
Numbers.
No, use colors which are
Not vibrant.
non-prone to the color blind. From the same source, the main tools to build decision-making platform or visual Power BI sensor. These are big data visualization tools. There are many more. Just read it. No question in the exam from this. Traditional data visualization tool, Power BI, Microsoft is one of the common one. Tableau is very next common one. Google Data Studio is there. Azure Machine Learning Studio is there. There are many tools which you can use it. Okay, for data visualization. That's the end of the slide. Any question on this? Very good. So we will Okay. So we will start from the previous place where we left, okay? This is Google Colab, right? I told you all will have a Google Gmail ID, right? Which you can use it to run the machine learning program. Only the drawback is every time you have to upload your data file, okay? So what we are going to do is I will use linear regression algorithm, okay? The easiest one, okay? Then I will give you one link where you can, or I will give you a link where you can read for the logistic regression. If you don't do it, then exam the logistic regression program will come. Okay. So I'm telling you the question also beforehand, right? So don't struggle that day, oh, I don't know what to do. Okay. So first step, what should I do? The first step, the very data processing, any system you do is you upload the data. Okay, whether you use Snowflake, whether you do Databricks, whether you use Google Colab, whether you use Azure cloud platform for machine learning studio, anything, the first step is to upload the data, right? So how should I upload the data? Let me see where the data is. There is Teams.
I think you have to upload it.
Yeah, I'm loading, I'm just getting the data from the drive. Got it. Okay. So this is the source data, okay? Last time we were doing this, right?
Yes,
So this data has how many columns? Not 5, 6, right?
6.
How many rows it is?
20.
250 something.
44.
44.
No, not 44.
9.
This is the age column. How many?
358. Can you click on the last one?
Yeah, now 376. 376.
Right? So it has number of columns as, sorry, row as 376, column as 6, right? Actual data is how many rows? 375, correct? Why? First one is label of the column, right? The actual data is 375. If I scroll you up, I will show you something in between. One is missing here, right? If I subtract one, how many left?
374.
This one?
373.
373. The actual data is 373. This spreadsheet is very small, right? So it is easy to understand, right? Think about if I have a data of 50 million record like this and a column of 200 like this. Understand? 200 columns and 50 million record. I need to run a machine learning algorithm to determine something, right? It's a tedious process. You cannot do like the way I scrolled up and down to find where the, and first of all, your CSV will not open. 50 million will not open in your CSV, right? It will take a lot of memory, your Excel will crash, right?
Yes.
So what I have to do is I have to do some form of machine learning to understand what data is. So the first step is, so I'm just keeping this spreadsheet open because we will be looking at this data again and again, okay? The first step is I will have to upload the data, right? You go here, double click it, upload, and you pick up the data set, add it, right? So this is a trial version. That's why it says that once you terminate the session, the data load will be gone because whatever Google has provided me the compute, it is for that particular session, right? If I don't use or if I log out, it will go away. When you work in a big organization using Databricks, Snowflakes, Azure, your data doesn't go. It resides in that location. So for me, my location where the data is residing is, if I click here, I can copy the path, right? Correct? And I can simply paste the path where my data is located, right here, right? But in case of big organization, like what we do in the organization, this is nothing but a path location, either a S3 bucket, S3 location, or Azure path like ADFS. If you remember that double colon backslash with the path of the source folder slash the file name. If you add it, you're good. It doesn't change until the source folder location is changed. Okay. If you change the source folder location, then you will get an error here. You will know what to change here. So don't worry about it. It's very simple. So the first step is you will start importing the library. So machine learning algorithm works on different languages. The simplest is used and most common is used is Python. Okay. You will import these library, import pandas as PD, import numpy as NP, import matplot library.py, Python plot as PLT, import seaborn as SNS. Right? Don't write, I will give you the code, okay? No need to write it. I'm going to send you all this code. Who will explain me why pandas are imported in Python?
Pandas is, it has machine learning library and maths library that helps with statistics and maths, like working with data.
Maths library.
Yeah,
Mathematics library. Very good. Like average, sum, count, average, standard deviation, mean,
Matrix.
sigma, whatever it is, right? All the maths related. What is NumPy used for?
It's for numbers. Working with lives.
What is matplot library used for?
Plotting and graph.
For data visualization, the slide which I showed you, if I have to draw anything in form of pie chart, bar chart, histogram, whisker chart, heat map, anything, I need that library, matplot library. Okay. What is Seaborn library used for? Seaborn library is used for sklearn and using the machine learning libraries. Okay. Clear? Fine. If you need more libraries, you can add it, but mostly these are the common ones used. Okay. First step, I run this. Okay. My libraries are loaded. Next step is what I am doing here.
Loading the data.
This step, what I am doing it.
Loading the data into the RAM.
Reading the field.
Guys, tell me.
Loading
You don't tell, okay? Tell me.
No,
Oh,
yeah.
let's see. Better?
Yeah. Loading the data and retrieving some of the header column, header rows.
Yeah.
Right word. Correct word.
Reading. Retrieving.
Yeah, this is read the path, but what is this variable going to do? What is going to happen?
We are gonna load the data to that variable.
It is gonna take the data from that path, read them, and upload
Yeah,
them to
objects
the
are stored.
variable.
We are gonna store it
To the object.
under this way.
In the first part.
No, this is separate. I'm asking only about this one. Guys, whole subject is finished. You people are asking it. What does Spark do? What was Spark going to do?
Data.
Huh?
Spark.
Spark, you people gave an exam, right? So did a assignment. What Spark does?
It's a data frame
Data frame.
object.
Data
Data
Very
frame
good.
object that has.
What word you use?
Data frame.
Data frame. What is data frame?
Data stored in memory.
I told you in the previous class, you people are completely drained out. One is called as data set and other is called as data frame. What is data frame? Data frame is the structure of the matrix of the data. Right? What does Spark do?
Creates the
Create
data
the
from,
data frame and
Data frame.
And then what happens?
loads it into the memory.
Very good. It basically this data is stored where? This data I uploaded it, right? This one was the data, right?
Data set, yeah.
I uploaded it. It's in the one of the location. Which location? Some drive, some disk, some location. When I am doing a pd dot read CSV to this location, I am creating a variable data frame, sal underscore data. The data will be pulled from that location and loaded to the memory of this instance, which is running on the RAM and the disk. If people forgot what was Spark at all, like how your people will be going and giving exam, and everyone got a good score, right? Copy paste it from the internet. No, that's not the way you. It's not. We are learning at this age. You people are very young. You should absorb more what I can, right? You have the data loaded from a location, bringing it to the instance of the main memory using Google Colab, right? When you load this, bring that SAL data, you are loading the data to a data frame. Where is data frame residing? In the main memory. You are not touching this data. This is your original data. Whatever manipulation I'm going to do in this data will not affect my original data. So machine learning algorithm never update or delete or remove or make changes to the original data set. Why? If you make changes to the original data set, what will happen? Tomorrow the data is gone, right? So you always take the data, bring it to the main memory or bring into the current instance where it is running. You need a CPU and main memory capability to process at a high speed. Had it been on a disk, it's then use Hadoop, right? Run machine learning on Hadoop. It will take years to do it. Not years, like it will take long time, right? You need a fast processing of machine to make predictions. pd.read CSV, I'm reading the data, bringing it to the data frame. Next command, I'm using the data frame. That frame name may be anything. Sal underscore data, ABC underscore data, whatever name you want to, dot head. Head will print the top 5 set or 6 data set to see what is the data look like. Right? It's like a
Preview.
head and tail in Linux. How many of you have used Linux?
Yeah.
Linux, right?
Yes, we did.
Okay, it's just to preview the top set of data. If I put instead of head, I put tail, it will give you the bottom 5, right? Clear?
Yes.
So when I run it, it gives me the data frame, right? I have whole 373 what odd data was there. Everything is here, but it is just showing me 5. Clear? If I put head in the bracket inside, I write 200, it will show me the top 200. Correct?
Correct.
What is the objective of looking at the data frame?
To have an idea of
To
what kind
confirm
of.
that.
Understand what my data constitutes of. The way I showed you the CSV Excel, you might not get the data to be viewed in CSV, right? If your record is 50 million record in a CSV file, can you open in Excel? You cannot open it. Can you know where the empty lines are there? Cannot know it. So what should I know? I should at least understand the structure of my data, right? So in order to understand the structure, I will say sal underscore data dot head. So it will show me all the columns. It will show me all the columns and top 5, 6 data. Once I read it, I understood, okay, my data has got age, gender, education level, job title, year of experience, and salary. Clear?
Yes.
If there were 200 columns, I have to just scroll it on the left hand side to see, right hand side to see it. Clear?
Yes.
If I don't want to do so, right? If I don't want to do no, I don't want to scroll. I want to see how many columns are there in the Excel or the CSV original data, right? There is something command called as shape. I take the same data frame that was created. And again, this data frame is a temporary storage in the main memory. Once I log out, the data frame will go, my file will go, everything gone, right? Next time you have to again upload it and do it. Clear? So that's why whenever even in the enterprise, you have to give the path and you run this notepad from top to bottom. So every time it loads the data to the main memory, consumes it, executes the machine learning program and log out. Two advantages. One is you are not constantly using the resource. You don't always need 16 gigs of RAM machine. Let's say I'm using Azure cloud, right? I don't need 16 gigs of RAM throughout the 24 hours. Whenever I need to run this machine learning program, I will run it from the top, it uploads it, sees the resource requirement, assign that machine, executes the program, logs out. I releases the resource, the cost is minimum in the cloud. Clear?
Clear.
Good. Now, if I do sal underscore data, this is my data frame dot shape. What will give me? It will give me the shape of my data set. So what shape it is?
375.
It tells me it has got 375 rows, removing the header and label. How many columns it is?
6.
Clear this one? You will do in the exam in the same way. What you are going to do is, whenever you are going to do any step, there is something called as text here. Right? Every line of code, there is something called as text. You will write what are you going to do here. Right? You write it and then you click outside and then you execute the code so that I understand what you trying to do it here is mentioned here and I will grade you. Clear? Any question you ask me, okay? Don't tell me, Professor, this was not explained. So this section, the one which I selected as text, is called as markdown. It's like a comment in rows, right? It's more for describing what you're trying to do. The other option you see in the Google Chrome. So there are two options, right? Code and text. Anything which you need to explain your command, you will write inside the text box. Anything you write will not be executed. It's you for your understanding. Anything you write it in the code block, it's something which you are going to execute the command. Clear? Now, I know that I have a column of 375 rows and 6 column, right? I need to know list of columns. List of column like 1, 2, 3, 4, 5, 6 were there, right? I know to know what the column means because my table was showing to me in the top, but I want to know what are those columns and what are the types of it. Okay, so I will take the same data frame, right? Same name, dot columns. Simple. When you run this, it will tell you the columns are age, gender, education level, job title, year of experience, and salary, right? So I run this. Okay, so my objective in this whole exercise is to, I have the data for 375 people, which has got 6 rows, right? I need a machine learning algorithm when I supply that core field. So you have this 6 fields, right? I have age, gender, education, qualification, job title, year of experience, salary, right? My objective is to build a machine learning algorithm that if the machine is given age, gender, education, qualification, job title, and year of experience, the machine should tell me what is the salary expectation of that person, right? So here salary is what? Dependent variable. Anything on the left hand side are independent variable. Your salary will be changing based on age, gender, education, qualification, job title, and year of experience, right? Right? Yes or no?
Yes.
More precisely, your salary will be changing with the education level and years of experience, right? That's the two very common way which you understand it. Again, this is more of a analytical skills. When you do machine learning, you have to start learning as in when you do more and more programming and doing more and more solution, you will be able to understand which data are dependent. Mostly when dependent variable, you always need what is being asked. That's a dependent variable. Any machine learning algorithm, something is asked to you, that is a dependent variable column, right? Dependent variable will not be anything outside this column, first case. Your machine can predict anything from these variables, right? They cannot predict anything outside the variable. So you cannot ask him that, okay, this is the data set, can you tell me which person is eligible for loan? There's no relationship, right? So your machine learning algorithm works with the data set provided. That's why this particular algorithm, linear regression, is called as, last time I told you, right, parametric equation, because it is deals with y equals to mx plus c or mx plus b, where x is 1, 2, 3, 4, 5 category. Y is this, I don't know slope m, I don't know intercept c. Clear? I don't have to remember the formula also, it's very simple to do. Till this point, how many of you have not understood any specific thing? Let me know, because it will become slowly difficult to understand, okay? Now I identified the column, right? Next is, I can rename the column. I want to keep the column age as it is, gender as and gender. Education level, I don't like this name, I will change it to degree. I can do the job title, years of experience is a big name, I just convert it to years underscore experience. And the last column is salary. It's a rename of the column. Clear? Now tell me, when I do a rename, will it be persistent or non-persistent?
Non-persistent. No.
You understand persistent and non-persistent?
When it changes.
Will the change in the column name on the original data set will happen permanently, or it will not happen permanently?
Not happen permanently.
Right. It will not happen permanently, because all the column names we are doing it on the data frame. Correct?
Yes.
You are making the column name changes on the data frame, which is a temporary location. You are not making changes to here. Clear?
Yes.
So I run this and you renamed it, okay? Now the next step is to identify the data types you have in your data. Data types, you understand, I told you, one is numerical, another is categorical, right? The objective is to understand which data is numerical, which data is non-numerical, right? So there is a command, this is a data frame dot date types, that is data types. What will happen? It will give me all the data type that are existing on the columns, right? So age is float, like an integer number, right? Age is 32.00, say number, right? Gender is an object. Object means it's a non-numerical data, right? We don't write string, we write object here, because here data is nothing but an object. Degree is again a non-numerical category. Object, job title is object. You see, I changed the name experience underscore years, right? Versus year of experience, right? So now the label has changed, it is float. Salary is float, right? So these are the data types, correct? So I will run it and we can recheck it. My data type should be visible. Fine. Now, what I need to know is from the data set, what you have, right? I need to determine what is the data information I can withdraw from the data set. Data information means how many non-null, okay, how many null are there, right? So that information I need to get it. For that, you will use a function called as info. I'm using the same data set, data frame name here, right? Dot info. So when I run this, so what do you get? There were 376 rows. One row was the label, 375. Two were empty. How many non-empty? 373. You get 373, 373, 376. These are non-null, right? It says data type float 3. There are 3 float, 1, 2, and 3. There are object of 3 type 1, 2, and 3, right? Memory usage to run that command is this much KB. Again, this is not useful. It is useful when you're running. Is this clear?
Yes.
Right?
Yeah.
Now, one thing to cautiously see here. There were 375 entry, right? 376, one was a label, that is 375, right? When you count 375, you'll count it from 0. You count it from 0, then it is how much?
374.
374. 0 to 374. Okay, it starts the index with 0. Okay, there are 2 null empty fields, right? Out of the data set. Clear? Now, what should be my task? Now, the task is 2. One is find the duplicate, remove the duplicate, and keep only one instance of duplicate, right? Second is, if I got null, I should do remove it. Correct? That's the simplest strategy, right? What I'm doing data pre-processing. Clear? How I'm going to do a data pre-processing? This is your data frame, right? right? This is my data frame. Data frame bracket, data frame dot duplicated. This is the method inside Python, duplicated. What it will do, it will read the data frame, like full 374 data set, and determine which are duplicates. Clear? And put it into the same data frame. Clear?
Yeah.
Okay, so if I run this, so you see there are so many duplicates, right? There's so many duplicate data, right? I think 20, 30 are data are duplicate. Okay. Clear? What should I do with the duplicate?
Should remove it.
Remove the data completely, right? But I need to keep only one match, right?
Yes.
So don't read this, right? This is my data frame, sal data
Yeah.
dot drop duplicates, right? I will drop the duplicate, parenthesis, keep equal to first. I just want to keep the first one occurrence. I can do this as a last also. If there are 20 occurrence, it will delete 0 to 19 and keep the 20th. If it is last, if it is first, it will keep the first and remove the next 19. Clear?
Yes.
But when this data will remove the duplicates, my data frame has changed now, right? It was 374, 73 records. Now, if I remove the duplicate, 374 minus, let's say 20 are duplicate. What are left over? 354, right? Right? It's a new data frame. So the natural way of, better way of doing is take the drop duplicate and put it in the new data frame. Right? Sal underscore data one. Right? If you all remember, I taught you something called an acyclic graph, DAG.
Yeah.
Right? When I moved, I don't follow a cycle. I just go forward, right? So this is the pre-processing. This is my first DAG, directed acyclic component. If I this execute, then only the next component, data frame one, will be coming up. So data frame one is dependent on data frame first, data frame previous one, right? Reverse will never be true. Data frame one can be become in data frame? No, because it is removed duplicate, right? It will never become an original data frame. That's why it doesn't do a cycle. If you all remember, if I teach, I don't know how many of you remember. Okay, now I want to see how much my data frame look like, the new one. Sal underscore data one. This is a new data frame. Dot shape. I did a shape earlier also, right? It was showing 375,6, right? Now it's 325,6. So what has happened? Duplicates have been removed, and I only kept one instance of duplicate. Now my data reduced from 374 rows to 325. So one cleaning is done, duplicate. What should be the next cleaning? I need to remove the null value of the data. You saw that 2-line empty, right? Let me run this first. Okay, so if you miss any step, the next step will not work. Okay, so in the exam, you will follow exactly the same way I'm teaching here. Your step will remain the same, exactly the same. Only the column name of the data will change and the algorithm will change. I will tell you how to write an algorithm, right? So that algorithm will change. Nothing else will change. So in the exam, you will find I've given you a few steps and I have written some command, do this step, do this step, do this step, and then I will give you another code. So in between, you have to determine what you have to do. Okay. So I will give you a very simple steps in between. If you miss it, you can refill that sentence. Okay, command. Clear?
Yeah.
Next step is to determine if there was a null value or not, right? How to determine null value? My new data frame is this, right? Now I will play around with the new data frame. I will not use the data frame previous one. Now this new data frame, again, this is also happening in main memory. I'm not touching my original data source. Okay. Data frame sal underscore data one dot is null. Is null function will see if there are any null values or not. If the null values are there, what is the number of count of that null value? Null value in terms of rows. Data frame, check the data frame one. Identify is null. If a particular row is null, tell me how many times it is happening, right? So if it is 1, it will show 1. If it is 2, it will show you 2. Okay. Clear?
Yeah.
Yeah, it will show 1.
Oh, we had 2.
0 and 1. Index starts with 0 and 1. That's the reason I showed you 0 to 354. Clear? You will not get this in the book. I'm telling you. It's very difficult to explain, then do it on your own. So it took 20 minutes for me to do it, and it was taking around more than an hour to explain it. So when you do it on your own, you will like it doing more and more. Okay, I can give you hundreds of problems to do it, but it's more of your practice, how much you do it. Okay, very interesting subject. There is a lot of jobs in this. Okay, so okay, you got this?
Yes.
Now, if I have found that I have 2 rows which is missing, what should I do with that empty data?
Remove it.
Remove it. Okay, I will just use something called as drop that particular row, right? So sal underscore data 1, that was a new data frame, right? Dot drop null attribute NA, how any, wherever you find an empty any, in place equals to true when the condition is true in that place. Salary, this is data frame name, new one, dot drop NA, drop that new line attribute, whichever is empty. How any of the column is empty. Like there are 6 column, right? Maybe 3 data is there, 3 column, other 2 is empty. Just take that data, any if it is empty, in place is true. In place true means if the condition is true in terms of empty data, just drop that complete row. Clear? Other strategy is you can do an average and then replace that mean value there. You can take a standard deviation 90th percentile and put the value there, the mean value. You can do that also, but this is for simplistic case. Okay, is this clear? You can again put it into a new data frame if you want. You can have sal underscore data 2 equals to sal underscore data 1 and put it in the new data frame, but I have not done it. I'm directly using it. You can do it. Clear?
Are we dropping like entire row?
Yes, the entire row will be gone.
But isn't it like less intuitive because we are losing data, right?
That's what I'm saying. It depends on what type of strategy you're employing. If you have like 5 million record and let's say there are 3 partial data missing, who is going to take average and mean and then put the data, insert there and save it, create a new data frame? That's a more, it depends on the choice. Like in case you don't want to lose a single data, then it makes sense that if the data is so crucial that you cannot miss a single data, then it makes sense, okay, I will take a mean and determine. But if the data is like 50 million record and you know that, okay, maybe 5 or 10 may be empty, it doesn't make any difference for me. You can just remove it. Even if that data was put in a mean, that will again be an outlier for you. It will not change much on your programming. Okay, so that's again a business need, right? How you want to preserve the data, how you want to maintain the data set. Okay, so if I run this, right, now I will again recheck the sample shape. Now it shows me 324,6. Earlier it was 326,6, 2 gone. Right? Clear?
Yes.
Good. Now something which will come is called as data visualization. Data visualization like plotting the graph. Okay. In order to plot the graph, it is called as statistics of numerical and column, data exploration and visualization. Okay. Whenever you do a machine learning programming, you need to understand the data and the relationship between the data. Right? For here example, age and experience is directly proportional to salary. Right? As you have higher age, more salary, experience, so you get more salary. So that's a common understanding. Data exploration is itself a science. Okay. So when we get a data with 500 columns, so we just simply don't go on reading all the 500 columns, right? We will do first data.shape and we'll see which are objects and which are numerical. And I will get the column name, right? And based on that column name, I will decide, okay, these columns are useful for me, these are not useful for me, right? So that's the way you learn it. In order to explore the data, one of the basic method is to describe the data. You have a data frame that is sal underscore 1, that's a new data frame. and you click on dot describe. So when you do a dot describe, basically what you are trying to do is you are capturing all the statistical metrics for that data. Age, year of experience, and salary. Total count of age is 324 rows. So all the 324 rows non-empty, everyone has got a count. If you can directly take out the mean, select all column in the bottom, you can write equal to mean parenthesis in the Excel, right? So it's calculating mean for you. Standard deviation, minimum 31%, 25%, 50%, 75%, the maximum value. Similar to that, it did for experience years and salary. Correct? What it did, when you describe the table or data visualization and exploration, it only choose the data which has got numerical value. Do you see here that degree? No, you don't see gender, right? Correct? So on what data set it worked on? It worked on numerical data to describe it. So I was asking something here. Okay, what is standard deviation? Quickly, we don't have time, quickly. Standard deviation is deviation from the mean point. So if you take a mean of a particular group of set of numbers, and if your values are left or right, you see how close is that with the deviation. Think about it, you draw a straight line that is a mean and you start walking over it. So the amount of position you displace from your center line is called as standard deviation. Standard deviation should be closest to zero. Closer to the zero, your deviation is less. Farther from the zero, your deviation is more. Both plus and minus. -2, -3, +2, +3. More the number of deviation, more the data is scattered. The deviation is very low, that 0.1, 0.2, 0.3, then it is very close to the mean line, denoted by sigma, if you study statistics. Okay, clear? Now, once you know this data, now I have to do the correlation. Now I have to correlate the data, how they are interrelated. Correlation can be done with the numerical column using a variable function called as .corr. That's a correlation function. What column I will use? All the numerical column, age, years of experience, and salary. 3 columns were numerical. This is my data frame. Put .corr. That's a correlation function, like how these 3 data are interrelated. I want to understand the correlation, right? When I understand this correlation, I use the function correlation and store it to the variable called it CORR. You can name any variable here. Okay, and then I execute CORR. You can also write print CORR also. Okay. So now when you execute this, what you see is, if I take a particular row age versus age is, if a row is compared on its own, it's 100% correlated, right?
Yeah.
There's no. If age is compared to years experience, it's 97% correlated. If I take age versus salary, is 91% correlated. Age versus year experience, same thing. Like if you see, it's just metrics, 3 by 3. And if you see diagonally, it's 1. Experience versus experience is always 1. Salary versus salary is 1. Age versus age is 1, right? So what does this tell you? If you have to do a machine learning algorithm, this step helps you to understand the correlation or a relationship between the data. Higher the relationship, higher the number, the better the way you can design your algorithm. You choose those columns that matches very close and resembling each other. Okay. This also helps you to remove the unwanted column which are not related. Let's say there are 20 columns with the numbers. If you do the correlation metrics, you will find it is 0.3, 0.2. There's no point of using the data because that data is not related to each other, right? So you can visualize it using a heat map. So you saw in the top SNS library which was used, right? Here, Seaborn, right? You can use Seaborn library to generate a heat map, right? SNS.heatmap correlation which you did right here, variable this one, CORR, annotate equal to true, Annotation, you know?
Yeah,
Where did you see annotation?
like books in like image have annotation.
Label. Okay, so if I run this, so it tells you what? This axis is 111, right? If you see age versus age is 1, years experience versus year 1, this is 100% match, right? Which is the next closest match? Experience versus age versus experience, 98. Right?
Yeah.
These two are also good, 92 is also good percent match. Okay. Now you can plot each of the columns in the different graph format. This is all data visualization, like how to look at the data. In the Excel sheet, it was not visible to you, right? How the data looks like. So what another thing is, this is a data frame. I took a very column called as degree dot value count, like how many value exists. So 370 for whatever values are there, right? For degree, right? So degree has 3 columns, 3 data set here, right? Bachelor's, master's and PhD, right? 3 values. So how many times bachelors are appearing? 192, master's 91, PhD 42 times, right? So if I do this, right, and then I use the same command, data 1, this is data frame dot the column name dot value count dot. If I do plot me what kind of plot I need. Bar chart, right? Kind equal to bar. You can put histo, HIST. You can do pi, PIE, whichever type you want, right? So why I am doing this is to understand my data distribution. If I see my bachelor shows 20. So if I present this graph, it is more readable, right? You can understand if somebody asks, okay, which of the people are having most of the degrees? Visualization helps you to easily make decisions, right? What other column you can do? You can do it for job title. Say sal underscore data 1. This is data frame job title dot value count to determine how many counts are there, right? So director of operation, marketing, senior manager, right? So there are different categories, right? I can plot it with the same till this is same, right? And just do plot kind equal to bar, right? So it will create a bar chart, right? Clear?
Yeah.
Again, it's very clumsy, right? Because there are so there are how many job titles in the Excel sheet?
174.
174 job titles are there, right? Different job title. How many rows are there? 373 something, whatever, right?
After the
325, right? I think after. So there may be some people who must be more than 2. There may be someone. So here it shows me that director of operation, there are 9 matches. So 9 places there will be people with director of operation. There may be director of marketing as 8. There may be a few people. There's are 111, right? So in between you see dot, right? So they don't show all up. But this is give you a clear picture. If you want to plot it, it just shows you. So you know the first one, which is the director of operation, is maximum, right? 8. So you know where the density of your data set is there, right? Clear?
Mhm.
Then you can do for gender. This is bar chart with a horizontal. Okay, so you can calculate male, female, gender, right? This is your salary one. I want to see what is the salary distribution. So I can see the salary distribution, right? So salary distribution, total count, total number of salaries I have, and you plot it with the histogram. Each bar, like if your salary is 0 to 5,000, right? Or maybe, I don't know, maybe 2,000 to 5,000, like that, right? Clear? Okay, now you can recheck the data set again. Okay, now the important thing comes. Now your machine language program starts from here. Okay, so this one all was your preparation work.
pre-processing.
That's why they don't pay you 150K, right? They pay you high, right? 150K for this work. If you are joining as a data scientist, they give you very good salary. So the first step is you did your pre-processing, cleaning and duplication removal. Upload, cleaning and pre-processing done. Now you will start doing feature encoding. What was feature encoding?
Changing to the
Numerical.
Non-numerical data to numerical data.
numerical.
Non-numerical data to
Numerical.
which are non-numerical data here?
Degree, job title,
Degree, job title.
gender.
Right? What I have to do? I have to convert somehow into numbers, right? Correct? How to convert with a number? Give me a second. I'll call you after some. Okay,
Yes.
so the first step is to convert the non-numerical data to numerical, right? The first step is, let's take column by columns. The first column is gender, right? What are the different values I can have for gender?
0, 1.
Female.
So here male and female, right? So I can have 0 for male and 1 for female. It can be reverse also, okay? Doesn't make any difference, right? What encoding will do is, it will take a column which is non-numerical. We will create another column. Listen to me very carefully. We will take a column which is non-numerical. Feature encoding will take this column, identify different combinations of things appearing, right? Different labels. So here labels are male and female, only 2 labels, right? I will create another column here, right? And label it with that number, right? Clear? In this case, in degree, what are different options I have?
3.
3 options.
0, 1, 2.
0, 1 and 2. I will take this column, create a new column, right? And encode it with that 0 and 1 and 2. Wherever it is, let's say wherever it is bachelor, I will put it 0. Wherever it is master, I will put it as 1. Wherever it is PhD, I will put it as 2. Clear?
Yeah.
Understood? Third is job title. How many job titles are we have? 176 job titles are there. I will start with 1. Director of operation as 0, director of marketing as 1, project manager as 2, senior project manager as 3, like that. I will do it. Correct? Now I will use that number wherever those data will come. I will put the number associated with that label. Clear?
Clear.
How many of you understood this? This is very important. If you don't understand, it's no point of going forward. Right? For every non-numerical data, I will create a label for that particular column and I will give a number associated with it. So there are 3 columns. How many I have to create?
3 more.
3. If there are 20, then I have to create
20.
20, right? Difficult, right? Very difficult. So we'll do it in one go. Okay. So don't worry, it is nothing, it is simple. You don't have to read this, you have to only write this. The first step is from sklearn.preprocessing import label encoder. The table I showed you, right? Label encoder, binary encoder, hash encoder, ordinal encoder. There are 5, 6, right? Label encoder is the simplest one. Okay, basic one. What does it will do is, I'm importing from sklearn.preprocessing. This is a package. Import label encoder method, label encoder library. Okay, I create a method label encoder and create an object of it. Like for example, what was it? I forgot yet. Mayur. Right? Think about this is a man and I'm creating an object of Mayur. Mayur will have the same feature what label encoder definition is there, right? Label encoder internally programming you don't have to learn. It's an already provided library in Python. Right? What it will do, I am creating sal_1 data frame. The same old data frame, right?
Yeah.
Which was created above, right? Create a new column, gender_encoder. You can give any name. I'm just giving it because gender was the name so that you remember, right? So gender is encoded to a new column, gender_encoder. If you don't want to put underscore, don't put it. If you want to put G, fine. Name is not important. Understanding is that gender is now going to be encoded, right? Equals to label_encoder, which is an object of a class or a library label encoder, dot fit transform. Fit transform means all that data in that column. Fit it and transform into a label. Which column I have to label it? sal_1 gender.
Original.
So the original column gender, take a fit transform means first read it. Read the data, transform into label encoder. So if he reads the data gender column, how many things he finds? Two. Either male or either female, only two will it find. So label encoder will do automatically wherever it find male, it will say 0, assign female as 1 because there are two matches only, right? And creates another column called as gender underscore encoder, right? Now your Excel sheet should look like this in the data frame. So this is your data, right? So basically what it is doing is it is creating something called as gender underscore encoder, right?
Yeah.
And it is wherever it is finding male, right? It is putting at 0. And wherever it is finding female, 1, 0, 1, right? Like I'm just putting it like this, okay? Clear?
Yeah.
Understood what it is doing? It is labeling each and every entity which it found in that particular column, label it with the encoding scheme which label encoder tells it to do. Here the label encoder has only got two values, so it uses 0 and 1, right?
So we didn't really need to check the type of, like how many types we had.
That's why I'm saying this is the advantage of machine learning. If I have got, take this as an example. Degree encoder, again 3 values, right? Label underscore encoder dot fit transform, column name is data frame and column name is degree. Let machine find it out. I am not worried about how many instances it find out and put it into a new label encoder, degree encoder. For this, it was 117.6 occurrence, right? Of
Yeah.
different type. I just do label underscore encoder fit transform salary and then use a job title column. Let the machine do it now. Why I need to worry how many matches are there, like different categories are there, right? And put it into a different label. Clear?
Clear.
So think about if you have 200 columns, 30 columns is non-numerical column, right? And you have 50 million records. Can you determine the column which all category it has? Manually, it's impossible, right? Even if you write a simple program, takes minutes to solve, right? The easiest is one method, just simply scans it, identify, okay, these are the category, labels it 0, 1, 2, 3, 4, 5, whatever it is, right? Good. Very good. Let's run this library, Now if I run the same data frame, new one, right? Data one dot head, right? I've just put 100. You see there are 3 columns added, right?
Yeah.
Do I need now these 3? No, I not need, right? Now this is number. This 3 are also converted into number and this 2 is already number, right? Everything is number. Now I can use anything, right? Okay, so there is one more step you have to follow, which is called as, you have to spend 15 more minutes. Okay, so next step is feature scaling. Feature scaling means when the two data are of different axes. Axis means if I see the age, I told you when I was discussing about the pre-processing, two data of different axes. If your age is ranging from 0 to 99, right? Year of experience may not be at the same scale. Same scale means if I draw X, Y axis, right? Let's say if I draw X versus Y, if I write Y here and X here for years of experience, the rate at which this will not grow at the same rate here, right?
No.
Yeah.
Right? So you can have slow high increase in the age, but low experience going up. Scale is not same. Have you seen a graph paper?
Yes.
Cubes, the squares are all same size, right?
Yeah.
You have always done a plotting where your X and Y changes with the same speed. Like same speed means 3,4. So everything 3 is 3 distance, 4 here distance. Both the scales are same, like it's a box of the same size,
Yes.
right? But in this case, boxes are not of same sizes. Your age has got different width with the change and year of experience has got different width. So the thing what you have to do is something called as feature scaling. You are going to bring, is it tough? Too tough?
No.
What happened? People are doing like this.
Very interesting.
Okay, so feature scaling, what we are going to do is we are going to scale both two variables on the same plane. Like I want to put it into the perspective that both has the same change, like x changes proportionately y changes. It shouldn't be like x changes little bit, y changes too much. Okay, so in order to do that planing, I use from sklearn preprocessing, the same machine learning library, import standard scalar. How many of you studied vector and scalar? No? Heard about it?
Mathematics.
Yes, physics.
Physics.
Scalar, a quantity which has direction, which has magnitude but no direction. Like I walk a distance of 5 kilometers. Right? That's a scalar quantity, but I'm not telling you where I'm walking, north, south, east, west. Vector is with direction. I'm walking 5 kilometers towards north. Right? So this is scalar, right? My data is scattered. I don't know the direction of the data. So what I'm doing, I'm taking import standard scalar and creating an object of that scalar, same way I did for the encoder, right?
Yeah.
Bring it back to standard scalar. Now, which two fields I'm selecting? I'm selecting age and I'm selecting years of experience. Sal underscore data one data frame, I create a new column of age underscore scaled equal to standard scalar, that's the object dot fit transform, same function, fit transform. Use the age column. Let the machine do the scalar identification. I'm not going to worry about how it is, what's the mean, where it is changing and how much it is changing. So this command will take the age, club all the age, find the mean value and then put the value perspective to mean. If it is less than mean, it will be negative, more than mean, it will put positive numbers, right? Same thing it will do for the years of experience, same data frame, years of experience. I added a new column equal to scalar, standard scalar dot fit transforms salary data one, experience in number of years. It will take both age and scalar in experience, convert it to scalar dimension. When you run it, and I will show you how the data looks like now. If I run it, and then I do the same head, right? So you see there is two more column added. I don't know if you all can see it. Let me bring up a little bit.
Yeah.
Can you see this? The last two column. What it is minus 0.75. One is your mean.
Less than.
So basically it is all the value you got, it took the mean of it, right? And let's say the mean is 37. I'm just giving a number. 32 is less than 37 or more than 37?
Less
So it will be on the negative side. By how much factor percentage? Minus 0.75 to the left. If you see the plus one, like let this one, 52, right? So you see the 2.03 on the positive side, right? So basically what I've done is I've taken the value of age and value of years experience and converted to a scalar axes, so that both the axes changes are represented with the same change. Okay.
Can we do it for salary also? Or
Salary is a
Salary is
dependent
dependent.
variable.
that's why.
This is you need an answer for, right? This is all which is given to you. You don't do the scalar conversion of encoder and this one because this is only categorical data.
So
Why
we are
you need a
processing
scaling?
The dependent variables. only.
Processing of the scalar activity happens on the numerical data, which is not categorical. These three are categorical, right? You convert it. Why will you do the category data to scalar? It is predefined numbers, right? The only thing that will changing is age and years of experience, but both data are not changing at the same pace. Right? Age of 35 years can have 12 years experience versus age of 35, another person can have only 4 years experience. How will you plot it?
That's true.
You cannot say both are same, right? Both are different data set, right? Clear?
Yeah.
Now, what you are going to do is, now this is dependent and independent variable, right? So anything which was your input will be stored in a variable called as X. Sal underscore one data one, that's a data frame, and I took all the variable which are my dependent, that is mx plus c, all the x value, all the column, right? These are
I think
independent and y is
Dependent.
dependent, right? I defined two variable X and Y.
I think you skipped the step.
No. This is just a head to represent the last two column, right?
Okay.
Scaling. Clear?
Yeah.
Yeah.
Now, if I did this, I want to see what X contains. So X should contain all this one, X, age scaled, year scaled, gender encoder, degree encoder, job and title encoder. You see, I'm only doing the X value with all numerical, right? And the next one, Y salary, right? So if I do this X dot head, it will give me only the particular column I want to know, right? You can do Y dot head also, okay? To see what all salary column you have. Now your machine learning algorithm starts from here. What you have to do is, you have to first create test, you have to train and test. And the third one is predict, right? What I told you, you will have to first get a random selection of
Sample data.
train sample data. Use it to pass it to machine to let machine learn, and then use the same another set of sample data to test it, right? Whether your algorithm works with accuracy. Once it works, then you use it for prediction with unknown data. Correct? 3-step. Do one by one. From SK, learn, model selection, import, train, test, split. What does split do? Break the data into test and train data. Clear? You don't have to do it. You have to just use the import that library, right? So 4 things will happen. X underscore train, like independent, what is that?
Independent.
Independent variable, X train. X train has got 4 or 5 column, right? Age scaled, experience scaled, and your encoder, right? What was that?
Job title.
Gender?
Gender encoder, years experience encoder, and
No, degree and.
degree and one
Position
more,
encoder.
position, job title, right?
So,
X train, what you need? You need some data for training, you need some data for testing. You need, when you use X train, you need an output to see how it is training, because you are going to supply test data, right?
mhm.
Random data, so that it trains.
Yeah.
You supply the X test data to
White is.
test accuracy of the data, 2 phase, right?
Yeah.
Train, test, split the same function, X comma Y. X, you remember the column, 4 columns you selected? Y, you know salary, right?
Yeah.
You see this X and Y, right?
Yeah.
What it is doing is X comma Y, which is above. X has got 4 column, Y has only 1 column salary, comma test underscore size equals to 0.2, means the split will happen 80-20. 80% will be used for testing, training, and 20% will be used for testing. Don't read it as 0.2 as for testing and training. It's reverse. Training will need 0.2 means 0.80. 1 is 100%, 0.80 is for training and 0.20 is for testing. Comma random underscore state equal to 42. It's a random generator will generate a sample data on its own from 325. You can change this number to 42, 52, 1, 5, 7, 9, whichever number you want. It's a random generator function. Clear?
Yeah.
What will happen next? Now I will see how my data looks like. So what did I do? I split the data, right?
Yeah.
I split the data X and Y. I have 4 combination, 1 for training, 1 for testing,
Y for
output Y for
training data.
Training.
training and output, and testing my output. These 2 are output, these 2 are input. Clear?
Yes.
Now I want to know, when I run this, I have split the data into 80 and 20. I want to see how the shape looks like, right? So X underscore train dot shape, Y underscore train dot shape. I want to understand what is the shape from the existing data set. So it gives me an output of 80% of the train shape. 259 rows it has selected for training with 5 columns, right? And the Y is only 1 column, salary, you remember?
Yeah.
It has only 1 column, so there is no back column. Understand? It has only got row, no column. Clear? So 80% of the data is used for training. So this shape helps me to determine what distribution I need to use. Normally it is 80-20 or 75-80 or 85-9, 85-15, whatever you want, or even 90.1 versus 90% of data for training. And sorry?
I have a question.
Yes.
You put like we choose only 42 column, right? Random.
Random state is a random generator. Right? So random generator generates a number and selects a row, particular row the data needs to be fetched.
So, so when we mention like test underscore size, it's like comprising of entire data set, right?
Yes, it comprises of entire data set. You are using the testing size for 20%, 80% for training.
I thought we are taking like 42 sample and then 80 to
No.
80.
If it's 0.4, that would
If you
mean
took 42 sample, it should show me 42 here, right?
That's why I was.
It's a generator, okay. Okay, now x dot test shape and y dot test shape. So this is your training. I want to see what section of the data you have used for testing.
yeah, that's the.
I'm just splitting it right now. I'm separating out which data I will use for training and which data I will use for testing. For training, I said I will use 80% of data. 20% of data I will use for testing. So I will do the same x underscore test and y underscore test dot shape, and I will get what is the shape of that. Like 65 rows and 5 column versus 65 rows I will use for testing. Clear?
Clear.
Now I will use model development linear regression algorithm. So from sklearn.linear model import linear regression. I create an object of the same function linear regression model. This is any variable name. I'm using linear regression method. Create an object. What should I do first? Linear underscore regression underscore model, same variable dot, rather than fit transform. I am not transforming it to any encoded value or anything. Dot fit. What should I pass? X underscore train, y underscore train. Whenever x is given, what should be the value of y? Y equals to mx plus c or b, right?
Mhm.
What is x train? X train has got x value. X has got 6 variable, 4 or 5 age. 5, right? X train will have it. So what is the corresponding y value with a linear equation regression algorithm using the formula y equals to mx plus c? It automatically does it for you. You don't have to determine. So what it is finding? It is finding slope. It is finding intercept. You're not doing mathematically, right? Clear?
Yes.
Next, if you have determined the y, right? You determine the y, right? Now I have to test the x. That was training. You trained it. Now I have to test the x, right? So linear underscore regression dot model dot predict x underscore test 20% of the data.
Mhm.
Put it in the variable y underscore prediction, give any variable name and get an output y underscore prediction. This is a variable name. It will give you the prediction, right? Then there are some other stuff you can read about it. I'm not going, I'm just showing you something important, right? These are all function, right? You can use error, like if your actual versus minus predicted is different, then show the error, find the absolute error. You all can read this, okay? I'm not going. This is coefficient. You can find root mean square of the variable. So important thing is, what is the accuracy of your algorithm, right? So it is used through this method or this package R2 underscore score, okay? So you can determine the score. So this algorithm has 89% of accuracy. Again, this you all can read it. I will just show you this as an example, okay? So this is an example which you need to know how machine learns, right? Let's say a question is given to you, a person named age is 49, right? Gender is female, degree is PhD, job title is director. What should the salary be if the experience is 15, right? My machine should answer it correctly, right? With a linear regression algorithm. So how do you do? So first is age is 49, right? So first of all, what did we know? When the age column is there, I need to match the age with the experience with the same axes, right? So I will use first standard scalar dot transform 49, whatever 49 is, to match with the year of experience. So I have to bring it to that scale, right? I name it variable age1 standard scalar dot transform. The variable count is 49, right? So it automatically transform that age. If it is 0,0, it will have two digit after decimal, right? So it will convert into age1 and I stored it to the variable age.
Mhm.
Clear? Standard scalar transform experience is 15, right? I need it to 2 decimal places. You can write it like this, or this is a single command, right? Years of experience underscore 1 equals to standard scalar dot transform 15. So what I'm doing, I'm taking age and years experience, converting into the scalar format that matches the excesses. Right? Same thing which was done during training. Right? Gender is 0. Male and female. 0 is 1. Female is
In this case.
whatever. Female is 0 and male is 1. Right? So I know the gender value, so I can directly put it. Degree is 2 because PhD 0, 1 and 2. I know the value. So I can, the ones which I know, I can directly put it, right?
Yeah.
Job title is 22 because director, I check the column 10 to 174 different instances. I just check which is the director position. I said, okay, that is 22. I just put it. Now what you have to do is you have to simply run it. So this is the data frame which is created again. Employee underscore salary equal to linear regression underscore model predict. Right? Bracket. What all values I have? Age, experience in years, right? Gender, degree, job title. Always remember that this sequence should exactly match to your X underscore train.
Mhm.
Yes.
X and Y are defined, right? The sequence should exactly match, otherwise your algorithm will fail. Because it is using this data feed, like age will be 15, experience will be whatever, gender equals 0, degree is 2, job title is 22. It will use the training template and run it. So when you run this, it runs, right? And then you can directly print it this variable. So this says if the person is of that age, the salary would be 24,925. Okay, I'm done, madam and sir. Thank you. So in the exam,
Like similar.
you will be having a same process to do the work. I'm stopping the recording, guys. Thank you.
When do we get this record?